Hello people, we are doing two questions at once in one video, so it's going to be a little bit longer. Just so I don't have to keep posting every like 2 minutes. But okay, so getting into it, I'll solve the differential equation. I'm starting here. No shit, this is question number one. But so if I'm just gonna write it down here first. So d theta over dt equals d secant theta over d squared. All right, so it's saying find a solution. Whenever they give you a differential equation and they tell you find a solution, you gotta split these bitches up. All right, so the first thing is I'm gonna start with the denominator, and this is theta e t squared, e to the t squared. And so first thing I can do is if I multiply by theta here, if I multiply this by theta, and I multiply this by theta, theta comes up and this cancels out. All right, so let's get rid of this nonsense, and so we'll get theta d theta over dt. Doesn't even look like a d, that looks like a, now it looks like a d. All right, and now what we'll have is t secant theta all over theta, well, not anymore. I'll have e to the t squared. Now the other thing is I can divide the whole thing by secant theta, and so that will take the secant theta to the other side. So now I'll have d theta divided by secant theta dt equals t over, or actually I'm gonna rewrite this, equals t e to the negative t squared, so it looks more beautiful. Now if I multiply by dt, I will get d theta over secant theta. I don't know why I'm speaking like this, but all right, and we'll have our dt. Now your secant, so side note here, your secant theta is equals to 1 over cos theta. So if this is 1 over secant theta, that means this equals to 1 over cos theta. And you can actually flip and multiply. So 1 over secant theta equals to actually just cos theta. All right, so we can rewrite this in terms of cos theta. I'm going to put this other theta in the front. D theta equals d e negative t squared dt. Now when you have this, you would integrate. All right, and so to integrate this, I'm going to do the left side first. So my left side is theta cos theta d theta. And so when you integrate this, what you'll do is integration by part. And how do you do integration by part? The formula, if we can remember it, is u dv equals u v minus v du. Is that how it is? Let's see if that works out. All right, so thinking about Liate. Oh, there you go. What comes first? We have trig. Your theta is considered as x. Is the same thing as an unknown variable, which is integration. So your u is actually equals to theta, and your du equals to d theta. All right, and then your dv equals to cos theta, and your v equals, so we'll integrate this and we'll give you sine theta. Right, and yeah, this is d theta. Your dv is the rest, so you see this equals this, and then your dv equals whatever is left. And what you'll do here, you'll plug it into this equation. My u is my theta, my v is my sine, all right, minus the integral of my u, or sorry, v du, so that's sine v du, my du is d theta. All right, so this would equal theta sine theta. The integral of this is negative cos theta. So this negative with this negative, that's plus cos theta. All right, and so that is my first integral, which goes in this part, or in this part. All right, so I'll actually highlight this in a different color. Do I have a highlighter here? Is this a highlighter? That is a highlighter. All right, what the fuck? Sir, is this good? Oh, that's too big, actually. Wait. All right, so this part is this part here. So far, so good. That looks okay. All right, now I will highlight the second. Actually, I'll highlight it after. So now we're integrating this part, and I'll integrate this under here. What do I have? I have integral of t e to the negative e squared dt. Now, before you see this, you're like, oh my god, another integration by part. This is actually a simple u sub. So you could do u equals negative t squared. You can just do t squared, but to make your life easier, make it a negative. Your du is my derivative of this. So the derivative is u minus 1, and you bring it down. This will be negative 2. You bring the 2 down, and then you keep minus 1, which is t, dt. But here, as you could see, if I'm gonna make this a different color, this part and this part is together, right? So that's the same thing as these two. So what I'm gonna do, how do I get rid of my negative 2? I can just divide. So negative du over 2 equals t dt. All right, so far so good. Now what do we do to my e negative t2? So your u would get plugged in. Just you my u would get plugged in here. And so what we'll end up getting is the integral of my e to the u, and then a negative du over 2. I put these in brackets because you can't do e to the u minus your du, so it has to be multiplied. So this actually is multiplied. And what you can do in an integral, you can pull out your constants. Since this is all multiplied, we can do negative 1 over 2 integral e to the u du. And e to the u du is just negative 1 over 2 e u. All right. And so this is our part 2. Pretty simple. There you go. And this matches this one. All right. And now what we could do, since this is all done, we can sub these two. So we have on the left side, this is our left side. So we have our theta sine theta plus cos. Actually, do I have space under? I do have space under. I'm going to put this under. Because on the left side, I'm going to do a second solution. So now I have my theta sine theta plus cos theta equals, and what we have on the right side is the integral here, which is negative 1 over 2 e. Don't forget, this is not in terms of u, this is in terms of t. So this is to negative t squared, right? And then don't forget your arbitrary c. Now, the right thing to do here, if you want to actually get the solution, since you have your d theta at the top, here you see your d theta is at the top, that means you have to solve in terms of theta, which means you have to have theta equals something. But because we have this, we can't really isolate for theta here. Yeah, because this addition really fucks you over, I think. But yeah, so you can't really isolate for theta here, so you can leave it like this, and that is your answer. Now we have the second solution, or this says find the solution to the differential equation that satisfies the given initial, this. So when they give it to you like this, you would basically do the same work we did up here, which is we are finding a solution, or we're actually solving the differential equation. But when they give you an initial, you see your plus c here, you don't want that. You want to get the actual value. And so first, let's write our equation, just like we always do. I'm getting a little talking break, my mouth is dry. There you go. All right, now the first thing you do to solve this is you want to isolate, have your one variable on the left, one variable on the right. So now we'll have du, and then I'll bring this up, so 2u, and then equals, I'll bring this on the other side. Well, I'll have 2t plus secant squared t dt. All right, now what we could do is simply integrate. So you'll have an integral here, and you'll have an integral here. All right, so first let's integrate the left side. 2u, when you integrate, you have a hidden one here. You do +1, and you divide by the addition. So now we'll have our u squared, and then we divide by our 2, which will be 2 divided by 2, which is just 1. So we don't show that. Equals the integral of this. Because you have a plus, you can actually integrate this separately. You can integrate this plus and the integral of this. All right? And so to integrate the 2t is the same thing as 2u. What you'll get is t squared plus our secant is simple tan t. All right? And that is my integral. I do have my arbitrary c here. Okay? And now what you want to do is you want to isolate for your u, which is pretty simple. I'll have u equals the square root t squared plus tan t plus c. All right, so that is my isolation. Now what we have is u, says u at 0 equals -5. Using this, we can find our c. It's a simple plug. So what we're going to do here, first, plug your 0, plug your t in. So we'll have, actually, or, I mean, you could plug both points in. So -5 equals the square root of 0 squared plus tan of 0 plus c. All right, now this goes to 0, and this goes to 0 as well. So what we'll have left is we'll have -5 equals the square root of c. Right, now the square root of c, we want to isolate for c. We can square root this side. All right, and that will give us 25. All right, now we're not done yet. You got to sub this into your equation up here. Okay, and so our equation up there, what do we have? Your solution would be u equals the square root of t squared plus, there's juice coming, by the way, don't skip this part. There's some juice coming after this. Since we are square rooting, don't forget your plus minus. And then you'll have your t squared plus tan t plus 25. Okay? Now, is this your final solution? No. Why is this not your final solution? Because so your solution technically here is your positive, whatever this is, and your negative, whatever this is. But this is contradicting. Why? Because what it says here, if you square root anything, it will always give you a positive number, right? If you can't square root a negative number. So here, what it says is t at 0 gives us a negative answer. So if we plug in 0, we go 0 plus 0 plus 25, this will give us the root of 25, which is 5, plus minus. But that's not true. We know that at 0, it's -5. So it is not true that it's positive, because that is contradicting. So the only one we need is actually the negative. So we do negative square root t squared plus tan t plus 25. See what I mean? And that is why you only grab your negative and not your positive. This is your solution. Thank you.